All right, Algebra 2, if you're coming from part 1, we just did domain and range. We did one example of domain and range. We talked about what it looks like, what it means, and some kind of good hints at the end. What we're going to do now is just talk about what we call end behavior. What we talk about end behavior. In other words, what happens at the end of the function or relation. We need to describe what's happening here. And let me kind of tell you what this is about. Let's go ahead and look at the setup for this. Okay. It says as x goes to positive infinity, this is their end behavior section down here. As x goes to positive infinity, our f of x, remember this is x and this is y, right? F of x is the same as y. So as x goes to positive infinity, f of x goes to, in other words, what we're trying to say, what we're trying to look at here and say, I'm going to kind of erase these for now, but as x goes to positive infinity, as my x values get bigger and bigger and bigger, here's what you do. Take your finger. You're going to trace the function to the right, because as x values get bigger and bigger and bigger, first you're looking, is there an arrow? And yes, there sure is an arrow. There is an arrow. And that arrow is pointing up. As my x values get bigger and bigger and bigger and bigger, my y values go to positive infinity. That is an end behavior. You're describing what happens at the end. Goes to positive infinity. Okay, so you can put your finger on. So this right here. This one is trace right. Put your finger right on the paper if you need to. Trace to the right. As long as it goes to infinity, you can describe what happens and why. If that stops abruptly, which we'll see in another example at some point, if that stops abruptly, it does not go to infinity. And therefore, there is no end behavior, and it does not exist. Now, for as x goes to negative infinity, put your finger on the function once again. And x value is going to negative infinity, mean I'm tracing the function left. My x values are getting smaller and smaller and smaller and smaller and smaller. My y values, however, are going up. What's up? Not much. What's up with you? But anyway, the up part, right? They're both pointing to positive infinity. Trace left. What you're just trying to do, look at the ends. Look at the ends. The left end, where's it pointing? The right end, where's it pointing? That's end behavior. Left end is going to negative infinity. Right end is going to positive infinity. Okay. You will always have this. You're only going to be filling in the blanks. Okay. Again, it's the fancy way of saying what's happening at the end of the function. Is there an arrow and where's it pointing to? Is there an arrow and where's it pointing to? Okay, now that we've done that, we've done one example, but what about a second example? Well, I'm glad you asked. Let's do a second example here. Again, we're going to put everything together. We did domain and range in the first part. We've just done end behavior. So if you need a refresher on domain and range, go ahead and look at that again. We can talk about it right now too. Domain, again, means your x values. Domain is your x values. What's your smallest x? What's your biggest x? And remember, we're reading from left to right. Well, if I'm looking left, it doesn't look like there's anything that x cannot be. There is no stopping point looking left. My smallest x value is negative infinity. Let's look to the right. This function's kind of going like this. My x values keep getting bigger and bigger and bigger and bigger. And if we go back and look at that one example, it says for domain, If on my right-hand side, it's pointing up right here, this is the thing that we got going on right there. If it's pointing up, my biggest X value is positive infinity. Well, this is nice again. Once again, I'm going to write it just for a second. We've got this negative infinity to positive infinity. If I had to write it out, it would look like this. But we also called that all real numbers because it includes every number. If I look from negative infinity to positive infinity, that means every single number is included. So again, we're going to use this symbol instead. We're just going to go with all real numbers. And for inequality notation, that's fine. And then for set notation, we're just saying the set of the numbers of X such that it includes all real numbers. Interval notation is a little bit different. We're going to look at our smallest x and biggest x again. So from negative infinity to positive infinity, we had talked about how it cannot include either of those things. You don't know the number for infinity. There's no exact value for that, so we can't put that in there. Let's go ahead and look at the range. Remember, we went left to right here. We're going to go smallest y. We'll go a different color here. Why not? Go back to that purple. Smallest y to biggest y, or down to up. If I'm looking down here, I've got no y values. The first y value I run in, this is interesting. This dashed line means that this function goes really super close to that, but doesn't touch. So in other words, I get really close to what's this y value right here? Well, if I'm looking up and down, this y value is 0. The y value gets really close to 0, but doesn't include 0. And we're going to be looking at some functions like that where it gets super close but doesn't touch. It's what's called an asymptote, okay? And now I'm looking here, that y value is 0. Now I'm looking for my biggest y value. Well, I've got this y value that's pointing up. Well, what's up? Once again, not much what's up with you. But if I'm looking here, the y value that's up is positive infinity. My biggest y value is positive infinity, right? So the smallest I have is 0. The biggest I have is positive infinity. Since I have an infinite interval, I'm going to write an x and the value that I've got. X and 0. Well, the smallest is 0. The biggest is infinity. So it's greater than 0, but it can't equal 0 because it doesn't touch. So this is just x is greater than 0. That's our inequality notation for, oh my goodness, I did it again. I know you're trying to get me here. Y is greater than 0. That's our interval note or inequality notation for range. Y is greater than 0. And now we're going to do the same thing for set notation. Y such that the set of all numbers, y is greater than 0, including y is greater than 0. In interval notation, we write the smallest number, which is 0, the biggest number, which is positive infinity. And since it didn't include 0, don't forget your comma in between. Since it didn't include 0, it wasn't exactly 0, we put a parenthesis around it. And since we don't know the number, we don't know an exact value for infinity, we put a parenthesis around that. Okay, that's our domain. That's our range. Let's talk about the end behavior. As x goes to positive infinity, I'm tracing to the right. My y values are pointing up. What's up? The up pointing up means my y values are going to positive infinity. They're going higher and higher and higher and higher and stopping without bound. They're unbounded y values as I go right in x. As I go left in X, if I trace left, this value is getting really, really close to something in Y. It's getting super, super close to the value 0, right? It's not pointing up. It's not pointing down. It's going directly along a value. If it just kept going, it just would get so infinitesimally small, the difference between that. It's going to 0. That's how we say that. Okay, that's a couple examples. That's a lot. Totally get that that's a lot. All right. Now that's your 1 and 2 level work. Your domain, range, and end behavior, just describing these things. Okay. Now what we need to do is we need to look at the graphing on a limited domain. In other words, we need to be able to take those linear functions we've been working with and graph them given some information. What do I mean by that? Well, let's take a look. It says for the given function and domain, draw the graph and identify the domain and range using the same notation as the given domain. Okay, that's a lot. We've been given y equals, or f of x equals 3/4 x plus 2 with a domain of -4, 4. And I'm seeing this in square brackets. So square brackets, because we got to use the same notation, right? This is interval notation. This is interval notation. So I know that when I do my range, it's also going to have to be an interval notation. Again, this one's already done for us, okay? My smallest x value, if I did it like a table here, my smallest x value is -4, and it can be -4 because it's got a square bracket. So whenever I plot this x and y, this is going to be a filled in dot, a solid dot. The same with 4 down here. My biggest value of x is 4, but it has a square bracket, so I can have a filled in dot. Again, this is because it's the left one. This is because it's the bracket there. Now I plug this in. The value of the function, if I input -4, so f of -4, the value of the function when x is -4, is 3/4 times -4 plus 2. Well, if I multiply this, I've got 3/4 times -4, do a little fancy work here. This ends up being -3 plus 2, which is -1. So the y value, or the f of x value here, would be -1. I would come in here and plot -4, -1, and put a filled in circle because it can include that. Remember when I marked wrong on some of you guys, hey, you didn't put arrows, you didn't put arrows. Well, sometimes you might not have arrows. This is those times. Okay. And now we can plug 4 in. The value when we input 4 is 3/4 times 4 plus 2, or 3 plus 2, which is 5. So if I input 4, my output, or my y value, is 5, 4, 5, solid dot, because again, it included it right here. It included the value in there, in the interval. And any x value in between would work. Not bigger than 4 or less than -4. So I can't go out here with x's. I can't go out here with x's because they don't exist. I have to go between these two values. This is graphing on a limited domain. So let's see here. We've drawn the graph. We've identified the domain. And now we need to do the range. The range, again, my range, what's my smallest y value? My smallest y value is -1. Down to up. My biggest y value is 5. And it includes those. My range, smallest value, is -1. My biggest value is 5. Both included, so I put square brackets using the same notation. Okay, let's try one more of these things. Then you're going to try one on your own here. So it says f of x equals negative x minus 2 with a domain x such that x is greater than negative 3. Ooh, I know that notation. This is set notation. So I have to give, if I was given my domain in set notation, I have to give my range in set notation also. And so what this is saying is, since it's greater than negative 3, x and f of x, or y if you want to get there, right? Negative 3 is my smallest value of x, because everything greater than negative 3 works. Not everything less, not things less than, right? It's also not equal to. This is going to be an open dot when I find this. And that's because it's just greater than. So if I plug negative 3 in here, so f of negative 3 equals negative 3 minus 2, or 3 minus 2, which I do believe is 1. I'm going to plot this point in here, negative 3, 1, with an open circle. But Mr. Brayman, you don't have another point. Yeah, you're right. How am I going to do this here? Well, I know that I can pick any value of x that's greater than negative 3 to find a second value. I could also use the slope. But here's a nice one. What's a value somewhere over here that's bigger than negative 3 that might be nice to work with? 0. 0, right? I could think of what 0 was. I could plug in 0. It's not an actual point. It's not an end point. It's just I'm drawing through it because I've got an open circle on one side and an arrow on the other because I'm going to infinity. This is called array, okay? And so I'm just going to put just a little dot here. If x is 0, the value of the function when x is 0, oh man, is negative 0 minus 2. Well, negative 0 is 0. 0 minus 2 is negative 2. So I could just I'm going to go through this point right there. So I'm going to take and draw through this point. And I put an arrow at the end because it's array. It's unbounded. My smallest is negative 3. My biggest x value is actually infinity, but I can't plug infinity in. I don't have that as a number. I just got to pick another number bigger than negative 3 to make this work. So it says, since f of x equals negative x minus 2 is a linear function, looks like y equals mx plus b, the graph is array with its endpoint at negative 3, comma f of negative 3. Well, we said the f of negative 3 is 1, so this would be negative 3, 1. So the endpoint is not included in the graph because it's just greater than, is not included in the graph. And the range, well, we got to look at the range. What's our smallest y value? Well, this arrow is pointing down. And if I remember correctly, pointing down, it would be negative infinity for my smallest y, my small y. And my biggest y, oh, it stops right here. My biggest y was 1. My biggest y value is 1, not including. Okay, so now we need to say the biggest is 1, and it includes everything less than 1. In other words, when y is less than 1, not equal to or equal to, just less than. And I need to put this in set notation, so I would say y such that y is less than 1. That. So again, if I'm wanting to do set notation, because that's what I was given my domain in, this is the range. It's okay. It's okay. What I'm going to do right now is I'm going to put a pause in the ed puzzle, and you're going to work out the last example. Okay, try it, do what you can, see how you can do, and when you click continue, I'll be right here. And here we go. The example is f of x equals negative half x plus 2 with a domain of negative 6 is less than or equal to x, which is less than 2. I know right away this is going to be a line segment. Closed value with negative 6. When x is negative 6, we got to still find the y value, but we know that this is going to be closed here and open here on the right. That's because it's less than or equal to here and just less than on that side. So since it's a line segment, since it's going to be a line segment, I have my smallest x value as negative 6. My biggest x value is 2. And this looks a lot like inequality notation. So we need to give our range an inequality notation when we are done. Make sure I'm doing this problem. So what we really need to do though is figure out, we need to plug in negative 6 for x and find out what our f of x or our y is, our f of negative 6. The value of the function when x is negative 6 is negative half times negative 6 plus 2. Well, a negative times a negative is a positive, and 6 divided by 2 is 3 plus 2, which is 5. So when x is negative 6, the f of negative 6, or the value of the function, is 5. Negative 6, 5. And I'm going to put a closed circle. That's because it could be or equal to. Now we know with the y value, it's going to be an, I'm sorry, not the y value. We know with the value of 2, it's going to be an open circle because it was just less than. So let's plug in 2. The value of the function when x is 2 is negative half times 2 plus 2. Well, negative half times 2 is negative 1 plus 2, which is 1. So 2, comma, 1. 2, 1. Open circle because it was just less than. And that x can be anywhere in between, which means my y values, because it's a linear function, would follow right along with that. Just like that. It does not have arrows at the end because it can't. And now we need to do the last part. We need to do the range, and we need to do it in inequality notation. My smallest y value, small y, is 1. My biggie, my big Y, is 5. This is included. This is not included. Sorry, the 5 is included. The 1 is not included. My lowest value, again, I'm dealing in Y now. My smallest value is 1. My biggest value is 5. I know it's got to be bigger than 1 and less than 5. And it can't equal 1, so I'm not putting an underline. I'm not putting the or equal to. But it can be 5, so I'm going to say or equal to. So this reads as 1 is less than y, which is less than or equal to 5. Which is less than or equal to 5. Okay. Actually, you got one more. You got one more. Okay. We do have another one. This is another ray. It's going to look a little bit like this. My biggest x value is 3. My smallest is negative infinity. This is going to be an array that looks something like this. Okay. Same thing we did with the other ones. This is an interval notation. I've got an x and an f of x. I have one value, which is 3. This is going to be a closed circle. And that's the hint I'm going to give you right now. Ed puzzle, go. Now that you've hit continue, let's finish this out. We need to find the value of the function. The f of 3 is 2/3 times 3, because that's x minus 1. 2/3 times 3 is 2, minus 1 is 1. So at 3 comma 1, I'm going to put a closed circle. But you're saying, hey, Mr. Brayman, infinities, or negative infinity is not a number. How do I plug another number in? Well, it's a great question. I just have to pick a number, because since 3 was the biggest x value, I just have to pick a number that's less than 3 to be able to draw through. And I think there's a nice one in here. It's called 0. That's really nice. 0 is less than 3. Okay. But again, what we're not going to do, that was weird. What we're not going to do is make this an endpoint, this 0, right? We just got to draw through this thing. We just needed another, because you have to have 2 points to define a line or a line segment or a part of a line. So if I plug 0 in, the value of the function when x is 0 is 2/3 times 0 minus 1, which is 0 minus 1, 0 minus 1, which is negative 1. 0, negative 1. So I'm just going to draw a little dot here so I can draw through it. This is just going to be a ray, so I will put an arrow on that point. Okay, and now I need to do the same thing. I need to do small y, my small e. I need to do my big Y. Well, my smallest y, this never stops going down. This will always, always continue to go down. What's down? Not much. What's down with you? Just kidding. I don't know. That's all I got tonight. This value is pointing in y to negative infinity. That's my smallest y. If I keep going up, 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 looking for my biggest y, I stop right here. My biggest y value is 1, and it can be 1. So if I'm looking to write this in interval notation, because that's what I was given the domain in interval notation, my smallest was, so let's go ahead and write this out. My range, small value is negative infinity. My biggest value was 1. It can never be equal to negative infinity, but in this case, it did equal exactly 1. That is my range. That is your 3-level type of work. That's a lot. That's a lot. We're going to practice this a lot. So you need to be on this. You need to get going. With Edpuzzle, I know how many of you have watched the video and when you've watched it. So let's do this thing. Ask good questions. We can knock this out. Take care. Have a great one.